This is Algebra 1, Term 4, Lesson 8, Tile Models. Today we'll learn how to represent the product of two binomials using algebra tiles. And we'll tie that in with the box method. And then the fun starts when we get to go outside and put chalk on the sidewalk. And we'll finish up with some really quick IXL practice. Let's go ahead and start on the Desmos activity. Okay, for the first part of our Desmos activity, it has basically nothing to do with this assignment. So let's take a look. We're going to do a little bit of marble slides for fun. This is a truly fun assignment for your class. I usually try to throw one of these in each term if I can to give them something fun to do. But on the marble slides, as they've done before, they're going to click launch and their goal is to see success. So I'm not going to do any of these for you, but just remember they will adjust these equations, click launch, and as soon as the marbles knock out all the stars, then they're finished with that marble slide. And then they'll do the same for all of these. So a few of these. They'll get to review transformations like making the graph steeper, translating left to right, up or down, and then restricting the domain. So all of those are in here for them to review. Good practice, good review. When they get to screen number 6, they're given a parabola already. It says type as many as you need in the rows below, so they will need to add extras here. They give them one to start, but they may delete that and try to do something totally different. Encourage creativity here. This would potentially be a good artifact in their portfolio, depending on how they approach it. But I have had students use these in their portfolio when they were real creative. They wanted to show that in their portfolio. So once we're done with that, we're going to get into something brand new. And this is algebra tile models. So we have been using the box method to multiply. It's really an area model. And now they're truly going to see an area because they're going to be manipulating these variables. So this is x and it goes from negative 4x up to positive 4x and everything in between. This represents the units. And again, they can go from negative 5 up to positive 5, anywhere in between. This is units also, but notice how it goes down the left side of the graph. And these are the x's. Now, the person who created this is real particular about the arrangement, and I can understand why. I'm sure it was a challenge to create this, so they have to get them to put it in the same place, or the checks are not going to work, and the directions won't make any sense. So here they're just asked to type in something they notice and something that they wonder. On screen 8, they're going to make an algebra tile model using these same sliders. So the first one tells us to represent this with tiles. Now I do say here for this model we should place our x on the top and our x plus 2 along the left side. But you definitely want to tell kids this is kind of arbitrary and it's only for the purpose of checking their answer, that we can reverse the order of our factors anytime we multiply because of the commutative property. We could even reverse the order of the addition inside the parentheses and it would be equal. So we're just making them all the same for this particular exercise so that the software can check their answer. So they need to know that. Kids sometimes make the assumption that just because it's done that way over and over, it has to be. And so that's why we don't want to lead them astray. All right, the first one, it says put the x on the top. See, I messed up. I don't want the x plus 2 along the top. So I'm just going to do the x, and then I'm going to do the x plus 2 along the sides. And when I do that, as soon as I do that, it'll say yes. So it's not going to say yes if they switch the order, unfortunately, even though they're equivalent. Now when they click this button, let x be a variable, it's going to show them that that length for x is variable. It can be bigger than it shows or smaller than it shows, and so it's basically showing them the definition of a variable by letting it move around like that. Now on this screen they're actually told to label this product. So what is this? What does this represent? What do each of these represent? So they can draw little lines to those and maybe use the math tool and label each piece. What are these? And then what is the simplified product? So they're actually writing a binomial for this here. So if you haven't already mentioned the term distributive property, or if a student has not brought it up, you may want to talk about it at some point, because here we have an x and we're actually distributing that x to get that expression. All right, now we're going to have a little fun. We're going to model several different one of these with algebra tiles. They're going to slide the x's and the ones to match, and then they're going to type a trinomial here. They do, in order to get the check mark in the dashboard, I think they have to put it in the same order. Like the first one would be on the top and the second one would be on the bottom. But if I were you, I would not count it wrong. I would just manually go through and check them myself to make sure they didn't reverse those, because we know that doesn't really matter. All right, and then here the same thing. They're going to put their binomials here, and it's going to draw the model and fill this in, and they're going to type the trinomial. So they're practicing this several times. Now to tie this in with that box method that they've already used, here we have a box. It's already filled in, so I'm just asking them to type a trinomial in this blank to match. You will have to manually check these. I don't think this one has the check feature in there. And then this one we're doing both. Now here's the binomial squared. I mentioned this earlier, but I had not, we hadn't done it yet. So you may note that this box is already kind of started. So if they didn't already figure out 3x plus 1 squared means 3x plus 1 times 3x plus 1, then it's kind of leading them in that direction with the box that's already drawn for them. So when this is done, you may want to talk about it. You know, one thing you could do is have a long conversation about 3x plus 1 squared does not mean just square 3x and square 1, does it? You know, have that talk. That's a great question to talk about, because that is a common misconception. But they will just fill these in. They can use the pencil or they can use the math tool. I do recommend the math tool for that. It looks a little bit better. Now don't forget to scroll down, because they do need to type a trinomial below. So you might need to direct their attention to that, because the directions are at the bottom. For this one, they're going to choose 2 expressions to represent this product. Now they do need to fill in the box, so they need to fill in all 4 quadrants there, and then come over here and tell me which of these 2 would be equivalent. And then this one is kind of interesting. It's a mix-up. It's got a little bit of the factors in there. It's got a little bit of the product in there. And can we figure out what goes in these blanks? And then you've got your algebra tile model to the right. So try to match them up. Make the model match the box. And then finally, they're going to create their own. And what's cool is at the bottom, it produces the binomials and the product that they're seeing, so they can kind of match and make sure their box and their tile models are the same. So this should take you most of your time. I have this lesson scheduled for 1 to 2 days, so this would take you 40 minutes maybe an hour. I guess it depends on your students. But once we're done here, we're going to go back to our slides, and we're going to talk about doing sidewalk chalk. Now here it says create a tile model and a box model both for the product of 2 binomials. Write the product as a trinomial. Now I know your kids won't think of this, but actually they probably will. But a lot of kids went over here to slide 16 and actually created their box and their tile model here. And they took a picture of it, and then they went outside and they kind of copied their model onto the sidewalk. It just made it easier to remember it. Some of them drew them on little mini whiteboards and took their mini whiteboards outside. Some of them drew them on paper. You could give them a piece of paper with this on there, and they could actually draw it onto the paper and then take it outside and put it on the sidewalk. Now you're probably wondering, why in the world do they need to go outside and put this on the sidewalk? Well, they don't have to put it on the sidewalk, but it sure is fun. It's a great way to take a brain break in the middle of quadratics. We've covered a lot of content. These kids especially the last few lessons, have been working extremely hard. So I usually like to give them a fun day like this one before we get into more solving quadratics, which is definitely not that much fun for a lot of kids. So I've really enjoyed doing it, and I've been doing it for many years. So let me show you some examples of student work. So here are examples of sidewalk chalk that my students did on the sidewalk, and as you can see, there are various problems. One thing I strongly recommend is that you suggest they stick with smaller numbers, because I had students didn't really think about that, and then they would come out here and it got time to draw it, and they were like, oh my goodness, I have to draw 52 tiles. And I'm like, okay, I'm sorry. So if they would have to draw it out before they go out there on paper, that kind of helps them realize, oh, I really need small numbers. So this person really took that to heart and used really small numbers. But you can see they're drawing their algebra tile model, they've got their box model, they've got their two binomials. I had them really, they were putting in coefficients. I think I got two of the same kid here, but these are great. And they also put these in their portfolios too. They took pictures of them, and it was just a fun day. It was a fun day. It did, it's not that it really helped them learn the math any better, but it certainly gave them an opportunity to get out of the building and enjoy some fresh air. And this was that year we had come back from COVID, so getting outside to me was kind of important. I wanted to get out of the building, so this was one way to do that. Now the last slide is just some IXL practice, and it's basically just a quick review, kind of like a summary of what they've just learned. So real quick, you don't have to do it really. If they're strong and they know what they're doing, you could probably skip this. But this is your IXL, and so they'll be given a model here, and they'll be given the binomials multiplied, and then they have to find the tile model that matches it. So most of them will go straight here and say, well, there's 3x squares. Oh, it's got to be that one or that one. Okay, let's see, there's 2 1s. Well, can't be that one, so it must be this one. And then they can see there's 7 x's. So anyway, once they do that, this number's going to go up, and I'll tell them to keep going until they get a 5 here. Once they get 5 questions answered, they can stop and just take a picture. I tell them to go ahead and answer the last question, even though it doesn't number it here, and just take a picture so the tiles show up too. But you can do it however you want. I just want to give them an opportunity to look at it one more time. And you get back in the classroom, you got a few minutes before the class is over, you want them to finish, have something to work on. This is just something quick they can do, just a little bit of practice. And that concludes our tile models lesson. Next time we'll start looking a little closer at those equations. Maybe we could write them in a different form. Y'all have a great day.